This is my heartbeat. It's going up slightly, well, slightly. It's a bit higher than usual because it's normally around 60, 70. It's not because I'm nervous or anything like that. I'm absolutely terrified. Because I'm going to do hardware demos. And all of these demos, they work at home. And about 4 months ago, I did a conference in London. I took this exactly the same stuff with me. I did exactly the same demos, and none of them worked. So you're up for a treat. I'm sure it will be fine. My heartbeat is stabilizing slightly, probably because this is the first hardware demo, and it actually works. So to prove that this is my live heartbeat, I'm just gonna take the heartbeat monitor off, and then, well, with a bit of delay, I have died. So this is fun, but is this useful? Well, maybe. So let's start with the actual talk. So the talk is fun with Bluetooth. The first question I always get is, why? Why would you want to use Bluetooth from a browser? Isn't that far too complicated? Isn't that unsafe? Why would you want to do that anyway? Well, the answer to that is progressive web apps. Progressive web apps are great. You get offline support, an app-like experience, and add to home screen, and in many cases, even a better experience than native apps. There is one thing that PWAs can't do. They're bound to what the browser can do. And they are great for talking to servers on the internet, but not so great for talking to devices in your home. To do that, you need native apps. But I don't want to download a 500 megabyte app on my phone, or the app is really crappy, or it was built 5 years ago and wasn't updated anymore and doesn't work anymore. Or I want to use my laptop or my desktop instead of my phone. And they only build a mobile app. And it's not just for constant use, it also offers a really good experience for setting up devices once, or every once in a while. So imagine buying one of those universal remotes, like the Logitech Harmony. And you have to download a really big application, install drivers, and why would you want to go just to a website, click connect, and you can set it up from the website. It's far easier. But why are PWAs or web apps not suitable for talking to devices? Well, my Sonos has Wi-Fi. I have these fancy lights, and they have Wi-Fi. And I use Philips Hue light bulbs, and they have Zigbee, but they have a bridge. It's connected to Ethernet. So it's all on the network. And they all run web servers. So you could use fetch or XML HTTP requests to talk to them. It isn't that difficult. Well, let me show you. This is an API that Philips offers. This solves our first problem, because devices on your local network have an IP address, but you don't know which. They don't have domain names. So there is an API for Philips Hue. You can call it, and you get the IP address of the device in your network. So we have an IP address, and we can connect to it. We can request some XML. Let's forget about that one. and we can authenticate. And that is really important, because nobody wants an unsecure IoT device. So Philips thought about this, and they actually require you to press a button on the bridge to be able to connect. So nobody can just change the colors of your light if they are on your local network. Sonos, on the other hand, doesn't have this security measure. So anybody on the network could just start playing really annoying music in the middle of the night, really, really loud. So I could walk up to my neighbor and, well, let's just say he wouldn't be happy with me. So Philips did the security. They allow you to request the API, you get a token back, and for further requests, you're going to use that token. So once you have the token, you can request the state of each light, brightness, hue, whatever, and set the state of the light. And that's basically all there is to it. Parsing some JSON, making some fetch calls. So why don't we build a PWA for this? So we're going to try to connect to the light bulb, to the bridge, and we click and we click and we reload and we click and we try again, and then we notice this doesn't work. And why not? Well, local devices can't get SSH, or can't get HTTPS certificates. So your HTTPS-only Progress web app can't talk to the HTTP-only web server on your devices. This is something fundamental that makes IoT devices really difficult to use from the web. And even if you were able to get a certificate, which you can't, because a certificate needs to be validated by the certificate authority, and it's on a local network, so they can't verify it. You can't get certificates for IP addresses, and your local device only has an IP address. So that doesn't work. The network is great for talking to remote servers, but not for local devices. There is a workaround. Philips created a public API. They allow you to connect to a public server using HTTPS, and it relays the messages to your bridge. And this is what they said. We are currently preparing for release of this remote API, which will initially be available to a limited number of partners. So this was 2 years ago, and it's still very limited because it just nests in Google Assistant and IFTTT, whatever. And even if you were able to use this API, would you want to use this at all? Because this is their infrastructure. So if you turn on a light, it goes somewhere to a server, somewhere, and then something happens, and then you'll get, well, a message on the bridge that turns on the light. So this is not really, well, optimized. So far, this has been PWA problems with local networks. And I promise you fun with Bluetooth. So, fun with Bluetooth. I know what you're going to say, Bluetooth. Bluetooth, well, Bluetooth sucks. And it's true. It's slow, it's limited range, you have pairing, but you're thinking about 20-year-old standard and 20-year-old technology. Nowadays, we have something different. It's called Bluetooth Low Energy, and all of those problems are solved. It's actually a modern standard. It's known by many names like Bluetooth Smart, Bluetooth 4, Bluetooth 5. That makes it a little bit more complicated to, to figure out what kind of device you have. And if you worried about range, the maximum range they managed to get working with Bluetooth 5 is more than 1 kilometer between devices. So they really solved a lot of problems. Right now, every day, 10 million Bluetooth devices are shipping every single day. And that includes mobile phones, computers, of course, but also devices like glucose monitors with serious medical applications. Activity trackers for sport and health, heart rate monitors, IoT devices like light bulbs, and even fun stuff. Not just serious applications, but fun little gadgets like Bluetooth robots or drones. What could go wrong? Fidget spinners. Oh, no. Let's forget about that one. So first, I'm sorry, we're going to talk about the boring theoretical stuff. The fun has to wait a little bit longer. When we're talking about Bluetooth devices, we're talking about central devices and peripherals. The central device is a device that can connect to peripherals, like your phone. A peripheral can't connect to a central device or to another peripheral. And once a central device is connected to a peripheral, another central device can't connect to it anymore. So there's just one connection at a time for a peripheral. So peripherals can't exchange messages. The drone can't talk to your light bulb if it wanted to. I'm not sure why, but yeah. It could relay messages using the central device, but you have to program that yourself. And we're not actually talking about the whole of Bluetooth here today, about a very specific profile, the generic attribute profile, which has a very obvious abbreviation, GATT. I don't know why they did that. Apparently GAP was taken and now we have to deal with GATT. And this is something you have to remember because this is something that comes back in the API. So when we're talking about GATT, we're not longer talking about central device and peripherals, but clients and servers. Your light bulb is a server. And I had to wrap my head around that because it's a light bulb. No, it's actually a server. And that makes sense because it offers services like light. And just like you use a client, a browser, to talk to a server on the internet, now you're using a client, your web browser, to talk to a different kind of server. And a server offers multiple services per device, and some of those services are standardized. For example, device information, which contains the manufacturer of the device or serial number, and so on. And light, which isn't the standard. A drone might offer device information and battery service, and flight control, which isn't the standard. Robot steering control, which isn't the standard. And an activity tracker offers heart rate, which is a standard. Unless you buy one of the cheap ones, then you won't get the battery service, nor the device information, and the heart rate won't be a service, it's something they thought of themselves. Buy a more expensive one, you do get the standard ones. A service contains characteristics, like manufacturer, model number, serial number, and so on. And it looks a bit like an array of objects. The server is an array of objects. The service is an object. The characteristic is a property of that object, and we have a value. And now comes the difficult part. Services and characteristics are identified by uuids and not names. That means device information looks like 180A and battery 180F. And if you want to have one of the custom characteristics or services, it's going to look like a 128-bit uuid. And of course, there is a reserved range which you cannot use, and everybody still uses. Why would you follow standards? So it doesn't look like this. It looks like this. And these numbers you just have to know. They are documented in the standards, but if you have a custom characteristic, this is something you have to figure out yourself. It's good for saving bandwidth, and bandwidth is limited with Bluetooth, so you don't want to push strings over the network. Each of these characteristics can be read, can be written to, and you can get notifications, kind of like add event listener. And every value is an array of bytes. There are no fancy data types, it's just a bucket of bytes. So, that was the boring stuff. So how does this look on a mobile phone? I have this app and I can inspect Bluetooth devices. I'll pair with the light bulb. It has a lot of services, device information, battery service. It's currently at 90%. But I'm more interested in one of the custom services. And it has a lot of custom characteristics. And I don't know what they do. I have no clue. Except for the top one. That one looks interesting. What if I change the value to something else? 0, 0, FF, 0, 0, 0, 0. And it turns red. What if I change it to 0, 0, 0, 0, FF, 0, 0? It turns green. What about 0, 0, 0, 0, 0, 0, FF? Can you guess? Blue, right. RGB. But what does that first byte do? Let's try FF000000. It's white. So there are 4 LEDs in this light bulb. And you can control the intensity of each of these LEDs using one of those bytes. So you can create any of the colors you want using just 3 of these 4 bytes. So, we're done with the boring part. Done with boring facts about Bluetooth. Now fun with Bluetooth. But first, there's an API in the browser for this. It isn't actually that difficult. Well, it's a lot more difficult than just getting to property values and arrays and objects. So it's a little bit more complicated, a little bit more verbose. So let's see how it works. You can connect to a device using navigator.bluetooth.requestDevice. And you can provide some extra parameters like the name of the device you want to connect to, or which services the device must have, or even which services are you going to use for security purposes. Then You call this, a dialog pops up. And you actually have to select the device. So this is important, because we don't want just any website sniffing your Bluetooth network. This is really important, because if it is possible to do that, there is basically another way to fingerprint yourself. So if you click on pair, you get a promise back. With that promise, you can connect to the GATT server. There it is, GATT. And when you do that, you get a promise back. And then you get the primary service, and you get a promise back. And you can get the characteristics, and you get a promise back. But it isn't that difficult. It's just verbose. Once you have that characteristics, you can do stuff with it, like write data. We can write some bytes using write value and a characteristic. In this case, we're going to leave the white LED off, and we have an RGB value. And this will change the color. You can read the current state of the light bulb using read value on the promise of the characteristic, and we get a promise back with the values. We can get notified of changes. This is particularly useful for a heartbeat monitor, for example. We use the characteristic, and we call add event listener on it. And we get the values as a callback. We must not forget to start notifications, because by default it is turned off, because we don't want to flood the Bluetooth network with all kinds of packets that are not necessary. So the things you need to know to play with this is Web Bluetooth API, which I explained to you, almost for maybe 90%. That this is it. Promises and typed arrays. Now, browser support is a bit sketchy at the moment. It's just Chrome and Opera, Samsung Internet on Android, and Servo, which is an experimental platform by Mozilla. And some of the features that land in Servo will move over to Firefox in the future. And there's another one. There is iOS support. Didn't expect that. Well, it isn't Safari, unfortunately. There is an app in the App Store called WebBLE for iOS. It is a browser, a full-featured browser, that supports WebBLE. I wouldn't use it for normal daily browsing, but it kind of works. It's perfect for demos. Then there's support in Electron, there's support in Node.js using a package. If you're still using Cordova, there's also a plugin for that, even on iOS. And the Puck.js, which is a little Bluetooth beacon, really small. There's a battery in it that lasts about a year, and it runs JavaScript. And it supports the API. So you can use this, there's a button in it, to turn on the lights, for example, by directly talking to a Bluetooth light bulb. Now, I mentioned that some of these characteristics aren't really standardized. So I encountered some issues. So this is the simple one. This is just 4 bytes. We've already gone through this. But I also have another light bulb. This one. It's a little bit more complicated. And it is a really unconventional way to write RGB, GBR. I don't know why they did that. It must have seemed logical to them. But it can get worse, like this one. And all of these bytes has to be exactly the same as this. If you change one of those bytes, it will not work. And you have to calculate a checksum. And there has to be a random number in there because, I don't know, no two messages can be the same, apparently. Yeah. I also brought with me a little LED matrix. It's basically just 8 by 8, just 64 light bulbs. So it's basically the same as a light bulb, except you have to specify which of the LEDs you want to change. This is not that difficult. I also have another one. Looks like this. It's kind of the same. Okay, it's a little bit more difficult. That is to change the color of one of the LEDs. So you're not going to figure that out just by looking at the data yourself. So you need some help to figure everything out. Like, well, we could hack it. We could sniff the network. So there's this USB dongle that you can use to actually look at the network on the Bluetooth network, at the data on the Bluetooth network. You can see all the packets that are being sent between the devices. And for most of the things, this will work. Most of the devices aren't that complicated. But for that last example, even with the Bluetooth sniffer, I couldn't figure it out. So there's a big secret. You can actually decompile APKs. So you download the APK for the application that the original manufacturer created. And then you decompile it, and you have the source code. So you can actually see the source code that the original manufacturer wrote. And, well, you can let yourself be inspired by that. That helps a lot. So now it's time for the demos. Finally the demos. I must warn you, though. This is experimental technology. It works at home. And like I mentioned before, I did this talk at a conference in London, and none of the demos worked. So this is not an exaggeration. And in conferences, it's actually worse. Because Bluetooth and Wi-Fi use the same frequency. And there are a lot of users with Wi-Fi devices here today. So there's a lot of interference. So let's just take a moment and get on with it. I actually don't want to know what my heartbeat is right now. So I'm going to ask you to tweet in a moment. And this is actually wrong. I'm prepared for that. I'm just going to front-end united. Good enough. So if you want to tweet something, please use this hashtag, and I'll explain later. Let's switch. And then, where is my mouse? There we are. So we did this demo. You'll notice I brought this light bulb with me. The change color while I was walking here. That is because it's sensitive to touch. But I'll just try to connect to it using the browser. I'll make sure. There it is. So it picked up that the color is green. That's a good thing. That means it actually works. And I can now change the color to something else. And as soon as I click on the color here, it will change the color on the light bulb. It's pretty much instantaneous. But that's not all I can do. I have some CSS here at the bottom. I could just change it. Orange, green. So what else can we do with this? CSS animations? Sure, that's possible. Oop. It works. I was kind of worried there if it was actually going to work, because there is a lot of interference here. It's a bit choppy, but it still works. That's good. So what else? Let's see what I have here. So I changed the hashtag here, so I did prepare, but I have this Bluetooth printer here. It's actually turned on. And every time somebody tweets with the Frontend United hashtag, it's gonna print that tweet on this little printer. It's a really, well, really crappy black and white printer. There it goes. But I still think this is really cool. So links are turned into QR codes. Yes, Conf is awesome. It actually prints images too. It then turns it into dithering black and white images. I'll just leave it on. Is this thing on? So the LED matrix. I'm going to turn it on. I love this thing because I really like just playing around with it, wasting my time, drawing cute little monsters on it, even when I have to work. But so let's try something. Now, I don't know which way it is oriented, because there's no markings on it. So let's try this. Yes, okay. I'm a professional. Let's try this. You'll notice it's a bit slow. That's not because Bluetooth is slow, but the device is slow. So. Yeah, that's a bug. It works. Please stop. Let's try this one. Not distracting at all. So we can do the same thing here. This one is a lot quicker. Oops. And another cute monster. So, I brought a lot of stuff with me. I'll just move this to the side. I brought a Lego car with me. And it usually comes with an IR receiver, but I exchanged it for a Bluetooth receiver. And that means I can use my computer to drive that car around. The table is quite small, so I'll try not to drive off it. Left, that is pretty safe. Right, that's also pretty safe. It works. Now, what else can we do with this? Something crazy. CSS animations, of course. There it is. I've defined some CSS animations. Those are keyframes, and I'm not used to a table this small for this demo. So I'm gonna quickly walk over to the table once I start this animation. There's a 2-second delay there. That is on purpose. I'm going to put it on the ground now. So it follows the track I defined with the keyframes of the animation. And this is just fun. It isn't really useful, but it is fun. So let's try something else. So you notice there is this big Lego head right there. I can connect to it. Maybe if I move it a little bit closer. It even lights up. There it is. Now there is something inside of this Lego head, a gyroscope. That means when I move this, oops, let's calibrate it. when I move this head, it actually moves on screen. Now this is something you could use. For example, if I turn this way, I could brake or accelerate, turn left, turn right. So, where's the car? Let's connect to the car. Make sure. Yeah. It is connected. So, this is more difficult than it looks. Oh. So, I'm going to leave that on. So, anybody with a modern Android phone with Chrome could go to bluetooth.rocks/racer and connect to that device. So, bluetooth.rocks/racer. So what else do I have? Oof. Well, there is another tab there. Yeah. I mentioned drones, right? I have one with me. So, I must give a warning. The first time I tried this, I killed some plants. And there's this little Lego figure on top of the drone, and it almost got decapitated. And if you're on the front row, I hope you're insured, because I have no idea what I'm doing. I'll try this. This is in no way distracting. So I'll just wait for it to start up. It takes a few seconds. In the meantime, somebody else, please don't connect to this device. That's not funny, because otherwise I can't control it anymore. So let's connect. Connected. I'll put it here. So there's this big red button there. That's there for a purpose. So once things go wrong, I fly into the screen or something, or into the public, I'll press the red button and it will crash on top of you. But at least the motors will be off. So let's try this. So this drone is literally controlled by Bluetooth right now, by my browser. Oh, a little bit higher. So I could point it anywhere and fly. I'm a little afraid right now because, oh, wrong way. This is pretty high ceiling. Let's see how high we can go. I'm afraid that once it goes out of range, I can't tell it to come back anymore. So let's keep it like this. I can't see. Am I over on top of that, the stairs there? Literally no control. And land. Now, I am going to turn this off and not leave it on like the car. The car. So this is a lot of fun. And everything you can do from the browser, that is the most amazing part of this. This is something that wasn't possible a few years ago. But it isn't just fun. It also has serious applications. This could transform e-health, for example. It could send data from heart rate monitors or glucose monitors to your doctor, and they can keep an eye on you in a safe and secure way without having to install apps. So, despite the serious applications, it is also a lot of fun. So thank you.
There's one overwhelming question that's been asked. Everyone really wants to know what's in your emergency folder.
In my emergency folder, yeah. That is actually there for a reason. I can show you. There are movies if the demos fail.
Nice.
So I wasn't kidding. I actually had no idea if it was actually going to work. But
amazing. Someone asks, can a browser tab connect to multiple devices at the same time, or is it one device per tab?
well, I showed you. I could connect to the Lego head and the car at the same time. So yeah, you can connect to multiple devices.
Oh, and then the other question we had was, I think way back at the beginning of your presentation, someone was asking what happens if you specify an invalid color?
Well, you can't specify an invalid color because there are 4 bytes. And each value of those bytes is a valid color. So what happens if you send 2 bytes instead of 4 bytes? Nothing. It requires 4 bytes. If you send 6 bytes instead of 4 bytes, it takes the first 4 bytes. But it depends on the device and what the device is actually.
Don't drive it down the stairs, that's mean. Children. Well, that was amazing. We're out of time, sadly, but please give a huge round of applause.
Thank you.